already. Yeah, it was a perfect introduction.
Mine was an introduction, yeah.
Yeah, it was a perfect introduction to my topic, to our topic. I hope you guys have had a good morning. I was a little bit curious how many people will show up after the evening event yesterday. Yeah, so but I'm happy the room is kind of full, and I would like to give you some understanding today and of also emphasizing on how traffic rules can be actually an operational asset in especially the topic what Dr. Dickmann said in homologation. Because as mentioned before, we do have many prototype approvals in the market, but very few type approvals for level 3 and beyond. Yeah, most of the type approvals for level 3 are traffic jam pilots. We have some exceptions on German highways, for example, in Nevada. But overall, there are very few type approvals. And we are developing a solution which helps using traffic regulations as an operational asset to create evidence for the type approval. So this is the short agenda. Yeah, I will not annoy you too much with a default company presentation, but give you some understanding about who we are, Ignite by FORVIA Heller. Then I will talk about the claim autonomous driving vehicles make and the challenges and our solution. And then I'm happy about any questions. So Ignite by FORVIA Heller, we are basically a software spin-up from FORVIA Heller, which is in the FORVIA context the 7th largest automotive supplier in the world. Heller has more than 34,000 employees and a lot of sales, as you see on the slides. Yeah, so it's a huge company and a huge legacy hardware player. So Heller produces many different devices. We do have battery management systems, obviously lighting systems, where Heller is very famous for, radar systems. Yeah, we have the colleagues on the conference here as well. They share a stand with NXP, so happy if you meet them as well. But we are the small software spin-off who's dedicated for software-only solutions. And with this solution we are showing today in the automated driving domain. And I kind of explain ourselves as a software spin-off with a 125-year-old mentor, which is kind of a good situation for us. But coming to the topic, so the claim what automated driving systems actually make when being on the road. If you look into the advances of automated driving systems, we basically went from rule-based systems to hybrid and modular systems, learning-based approaches, and end-to-end driving. Rule-based systems have been, a lot if-else, PID controllers. Yeah, we started in a way to kind of rule the world and to understand like what do we need to do with these distances and find the perfect software engineering approach to this. With hybrid modular systems, especially the perception system went kind of AI-based, yeah, so convolutional neural networks, understanding where objects are, understanding the road network, yeah, therefore we developed OpenDrive. So we created engineering tools to see the advances or basically make advances in the driving performance. Learning-based planning, then the later part of the system went learning-based, reinforcement learning. We heard that in the keynote from Neo yesterday is still a large topic. And obviously now with end-to-end training approaches, so training everything together from the sensor data to the actual planning task is bringing a lot of performance, while also still using convolutional neural networks for perception and visual language models for perception. So we have a lot of technical advances. And also in the keynote from AVL yesterday, yeah, we heard technical challenges are kind of solved now a little bit. Yeah, I think we made huge successes in this. I'm very happy to see that and how good we get in fuzzy logic in actual driving tasks. So we do have a driving performance which is going largely up. We ran into kind of some plateaus, yeah, where we had a hard time to get better. So we had to innovate and create these new approaches. The overall task is to become better than the average human driver. Yeah. By statistics, some say we are already there, some say we are not there, but we are at least very close, and I'm sure we will bridge the gap very soon to this. This is a qualitative diagram, yeah? So please discuss me on that. I'm very happy if you discuss me and challenge me on that. if we look into the driving explainability for automated driving systems, at the start with rules, we've been very explainable. Yeah? We've been able to understand exactly what was happening and why is our system behaving like this. Now we kind of go lower, especially with the end-to-end approaches. So we kind of are shifting from a white box approach to a way more performant black box approach, which is, yeah, as Dr. Dickmann said as well, a challenge for the homologation because we have to show evidence in homologation. And every car which is driving around, being prototype approval, if you are in a city and you see an autonomous driving car, yeah, it makes the claim, I'm compliant to the traffic laws. And that is what I'm going to talk today about. We develop a solution for traffic laws and how to map, monitor traffic laws and use them as an asset in the autonomous driving task. For global scale, basically. Yeah? Not just for German highway, for German city too, for Spain highway, and so on and so forth. But we come to that later. So the claim is there, we are compliant to traffic laws if we see an automated driving car. The challenge of becoming type approved. Yeah? I think some of you might know the Vienna Convention on Road Traffic from 1968. There are some amendments to it as well, who are relevant in the market as well. So it basically implies already that also automated vehicles have to be compliant to traffic regulations. So to traffic laws, in Germany STVO, for example, yeah, and, but also to traffic regulations. This is implicit. If we look into other regulations who are currently operational, we see that also the safety principles from the UN ECE, it not only implies regulatory compliance to traffic laws, it explicitly mentions it. The 157, which is the regulation in application for automated lane keep assist, is explicitly also demanding a monitoring of the traffic laws and the compliance of it while operating. Then we get also EU regulations, who again explicitly mention regulatory compliance to traffic laws, and this is becoming way more. I was observing yesterday a talk from the TÜV Süd, for example. Yeah, AVL mentioned it too. We all know there are upcoming new standards who are even more explicit. Even more explicit. And this is not only the case in Europe, what some might think. Yeah, so if we look into the global scale of regulations and the implicit versus explicit demands on compliance to traffic regulations, I created 3 categories. Yeah, also, please, I'm happy if you discuss me on that. But red is very explicit. We have to show evidence in homologation before we are allowed to go on the road. Before we are at all allowed to go on the road. The other way to do it is basically the prototype approval, yeah, like also mentioned from Dr. Dickmann. So you basically get an exemption for a specific ODD. But the automotive players, they want to scale globally because, like, what is the value in actually bringing an automated, like a pilot, to just Germany? There is probably very limited, sales impact on this compared to global scale. So we do have Europe, yeah, which is very explicit, and then we have the dark blue color, which includes China and India as huge markets, Brazil as well. India is making approaches to basically take up UN regulations as well. China is developing their own ones. They are also very strict, the Chinese regulations. So it will become more and more. And OEMs or tier 1 system providers or stack providers need to deal with this topic. Now it becomes a little bit detailed. Yeah, so please take care, follow me on that. I will animate in to enable you to follow the slide. So you saw the world, right? And for each of the countries in the world, we have to find the relevant scenarios on each ODD. So I brought here the scenario overtaking on the right, because I think it's a rather nice example, because in Germany, people usually think it's not allowed to overtake on the right, compared to the US. But there are actually legal ways to overtake on the right in Germany. And there are many, many scenarios. For German highway, we have about 50% of nominal situations. If we look into nominal situations, which are non-critical, about 50 scenarios. And you see the ego vehicle here, which is basically overtaking multiple cars on the left. And the regulations behind this includes STVO paragraphs. It includes court rulings, which are very important not only in Germany, also in other EU countries, in the US especially. And it includes also UN regulations. And I will not go into detail in this too much now, yeah, but you have, for example, about the distance you are allowed to perceive or need to perceive when driving at 130 kilometers. You have to see 150 meters in advance. It's a lot of regulations regarding this, and not only this, it's also the parameterization of this. So this step, if you are aware of which paragraphs are relevant for which scenario, there is still the missing part of it's still ambiguous. So we need to make it unambiguous as much as possible with parameterizing these traffic regulations and finding the right velocities allowed, the tracking distance in front, and so on and so forth. We have to parameterize everything, and that we have to do for each highway in the world for overtaking on the right. It's getting a lot, and for all the 50 scenarios. You have, just for highway, city is even more complex. So what I want to show here is that the topic is very complex. It must be targeted with raising regulations and raising demands. And the technical services, I'm very sure, will challenge the OEMs or system or stack providers on this largely. So what do we do with this now? It's a lot. Every stack provider or OEM has to deal with this topic. So the context is, yeah, it's ambiguous still. It's written not for a machine. In none of the laws you see the word like ego vehicle. Yeah, it's really it's the language lawyers speak. So it's still ambiguous, and the challenge is to make this machine understandable, to ingest this knowledge and make autonomous cars accountable for these regulations. And we basically have two ways. So in the German Safety Council, Deutscher Sicherheitsrat, yeah, I'm part of there and of this, and we discussed whether we just propose to change the German STVO to make it machine-readable and unambiguous. Imagine that again at global scale. How long does it take to make traffic regulations unambiguous at global scale, bring new STVOs globally in application? This is an option, I have to show it, yeah, because the other option is obviously the one we are preferring. We want to formalize the traffic law, remove ambiguity, and enable autonomous vehicles to understand the law and utilize it while driving. And this is what I'm going to show you with our solution, Ignite Driving. What is Ignite Driving? It's basically a traffic rules engine. So it's basically a framework to enable autonomous vehicles to understand the context, the legal context. And I will show you in detail how we do this. But before that, I will let you know, yeah, we can deploy this solution in your simulation. We can deploy it off-board in the cloud, in your cloud, to be connected to actual cars or a testing fleet. And we can deploy it on edge. And we are preparing the on-edge development to be ASIL-D compliant. Because without functional safety, it will be very unlikely this information can be used for the actual motion planning, which is why we are also creating a solution for embedded. Before I go into detail in the solution, I want to show you a short demo. It's just a demo, but you see a car here. This is our ego vehicle. This is in the simulator color. And on the right-hand side, in green color, you see paragraphs where the vehicle, as of now, in this current situation, is legal towards. The red ones, they will be pinned below, so you are able to see them in a little bit better way. Those are the ones we are in compliant with. And this is a showcase for German highway. Yeah, and I will just play it, and you will observe that basically we understand the environment, we perceive the environment, and based on the now unambiguous traffic laws and also regulations, this only shows STVO. You have 157, many parameters. It's basically a proof tree behind it where you can look into, you see the monitoring of it, and if you have a testing fleet, you can connect it, and you are able to show evidence of, like, we are driving 98% compliant. Technical service, let's look at the 2%. Yeah, let's look at the 2% and understand maybe it's even sometimes. There is an example about, I think, a Waymo car not passing a garbage truck and blocking the street because there is a continuous line on the road to the left and it doesn't overstep the continuous line. Every police officer will say, just like, be sure, like, make sure it works, and then it can overstep it. I believe this is some years ago, so probably they have solved the situation already. But yeah, this is what we bring to the table as evidence. And as I said, this is just a demonstrator. The solution behind it is large, and we are not the expert for the simulation. Yeah, we are the expert for making traffic laws machine-readable and understandable. So how do we do this, or how are we sitting in the kind of ecosystem of the motion planning and perception system? A short disclaimer here, we don't demand, like the solution doesn't demand to sit in between the perception system and the motion planning system. Those have still their regular connection, it's kind of a consultant in between. And we need information from the perception, and we look at each individual paragraph to understand what is needed to judge, is this one compliant or not? And the output will be three things. One thing is what you have seen basically in the demo is the vehicle in a legal state? Is there anything in the current state of the vehicle not compliant to any law? The second part is what maneuvers are allowed to be initiated? Are we allowed right now to make a lane change to the left? Yeah? Are we allowed to, as of now, brake hard? Emergency brake, initiate emergency brake. So we are all the time, in real time, evaluating which maneuvers in each situation would be able to be initiated. If you think of a lane change to the left, you have to consider the dashed line. Is it a dashed line? Is it a continuous line? You have to consider, is the vehicle next in the other lane to the left? You have to consider, is a vehicle coming with high speed from the left? You have to consider, is the lane maybe closing in front? And this is how we kind of logically connect these individual paragraphs to then make a binary decision on, is it allowed to initiate or not? And the third part is execution. So 157 is very precise on this, actually, because 157 says, gives a lot of parameters. A lane change maximum time to take is 3 seconds. If it's 3.1 seconds, it's not compliant to 157, as an example. And we are just giving the transparency to the motion planning system about the compliance. We are not implying changes on it. We are not saying, now behave like we want to do it. It's not the case. We are just giving transparency about the current legal state. And inside our driving solution, we have the observer, which is basically just a custom interface to the customer, yeah, to the perception system. Depends on kind of the format, the interface, how the perception data is being exchanged. The ruler is the core component where I will talk a little bit about, and the provider is just, again, the custom interface to how the motion planning wants to perceive the information. Do they want always to understand, like, which maneuver is allowed to be initiated, or do they pick it up from somewhere? Yeah? Do they use an application interface? This is just also a custom one. And this information can be used for in-service monitoring required by regulation, for safety-critical occurrences required by regulation, for field records required for evidence, for homologation, or even for the infotainment system maybe, because the topic of explainable AI and automated driving is also a large one. Maybe we can show some compliance things in the head-up display or in the infotainment system. There are multiple things to utilize this data. Okay, I have to speed up a little bit, yeah, but this is the part where I explain basically how do we create our IP. Because as of now said, we make it a machine understandable, and now I want to give you a little bit more understanding on how we actually do that. So we create legislation packages. And here is an example for the German highway, motorway. Yeah, this will be my example. And these are the regulations which apply on the German highway. This will be different for Spain, for US Texas, US basically in every state. And then we have a non-hierarchical collection of rules. They are all requirements which have to be fulfilled. And the paragraph 7, for example, says, yeah, in German now, I don't have my laptop, so I don't have my notes, but it basically is the paragraph for driving on the right, yeah, or one of the relevant ones, or overtaking on the right, sorry. Yeah, so it's text. So for each paragraph, starting here, we start the rule formalization process. We are creating an approved English version of it, yeah, with the wording of the Vienna Road Convention, for example. We make a breakdown of paragraphs. Often there are actually more rules than one in one paragraph, sometimes out of context even. So you have to kind of make a well-structured one below this one. And we compose the rule, and we understand what inputs are needed. We understand what are exceptions, like when does this rule not apply. And we understand whether the rule is accounted for execution, state, or initiation, what I showed you before. And after that, we kind of have approved requirements. We work together with the TÜV Rheinland on this. So they kind of approve our process, and they say, like, we want to use this for homologation. And then we have detailed requirements also for your V-model, which is very interesting for your V-model as well. And they are parameterized. If they are not parameterized, we go into the rule parameterization process. So either we find understanding about like specific parameters with experts, with lawyers, or in regulations. So sometimes we logically connect STVO rules with also 157 rules as an example, because the 157 just makes the STVO rule explicit for the ODD German highway as an example. Yeah. So we logically connect these. So we remove ambiguity with this, and this goes into the ruler component. Maybe you are familiar with ontologies. As of now, we don't use ontology anymore, but we basically have a world model with classes, and we create the IP inside the ruler, and this is exchangeable over the air if you cross a border, or if you cross a ODD. If you take off the highway, for example, you have roads outside build-up areas. If you go in the city, you have urban areas. So it's interchangeable per car in the cloud, or on edge in the car in the HPC. Really depends. Coming back to the closure, I don't have much time. We think about this, there's a huge gap. And what we basically propose is to complement end-to-end AI systems who are rather black boxy, not too much understandable, with a white box approach, to make the whole solution understandable in the end, and explainable and type approvable in the end. Yeah, thank you for your attention.